My name is Simon Jeromogo. Welcome to Semester Mathematics tutorial session, and in this session we will explain standard deviation as a measure of dispersion. What are the measures of dispersion? Examples include range, mean absolute value, variance, and standard deviation. Why do we need to study measures of dispersion? Let's take about 20 seconds to think about it. Let us now check the example below where marks of two students, Mary and Tom, in 8 subjects are shown in the table. The mean of the two students is equal to 56. What is the significance of this mean? Mary's marks are 5 points away from the mean, while Tom's marks are about 8 points away from the same mean. This means that Tom's marks are much more spread out than those of Mary. How can we benefit from such information? 1. This information can be used by teachers to determine the best method of responding to individual needs of each learner. 2. It will also help teachers to know areas of weaknesses and strengths of their learners in a particular subject. 3. Measures of dispersion are very important during decision making. What is standard deviation? Standard deviation is a statistical measure that shows the spread of values in a particular set of data. It is the square root of sum of square deviations from the mean divided by the number of observations. Thus, standard deviation is the square root of mean of the square of deviations from the mean. This will become clear when we do examples. What is variance? Variance is the mean of the square of deviations from the mean. Therefore, standard deviation is equal to the square root of variance. Let us now calculate the mean, variance, and standard deviation of the following scores: 10, 8, 10, 8, 8, and 4. To calculate mean, add all the numbers and divide the result by the number of items. That is, mean is equal to 10 plus 8 plus 10 plus 8 plus 8 plus 4 over 6, which is equal to 48 divided by 6, which is equal to 8. To calculate variance, add all the square of deviations from mean divided by the number of items. Therefore, variance is equal to 10 minus 8 squared plus 8 minus 8 squared plus 10 minus 8 squared plus 8 minus 8 squared plus 8 minus 8 squared plus 4 minus 8 squared over 6. This will be equal to 24 divided by 6, which is equal to 4. To calculate standard deviation, we find the square root of variance. Therefore, standard deviation will be equal to square root of 4, which is equal to 2. It is good to note here that standard deviation purely depends on variance. Let us do an example. The age of some grade 1 pupils were recorded by their teacher as follows: 5, 6, 6, 7, 7, 8, 8, and 9. Part A. Calculate the mean age of the pupils. Take 1 minute to calculate their mean. You are expected to pause your video for the 1 minute when you're working. To calculate the mean, add all the numbers and divide the result by the number of items. In this case, the mean equals 5 plus 6 plus 6 plus 7 plus 7 plus 8 plus 8 plus 9 over 8. This is equal to 56 divided by 8, which is equal to 7. Part B. To calculate variance, let's fill the table below, where X represents the grade for each student, D, the deviation, represents the grade minus mean, and D squared is the square of D. Take 2 minutes to complete the table. You are expected to pause the video for the 2 minutes as you work. To calculate variance, apply the formula summation of D squared over N, where N is the number of items. So, variance equals 4 plus 1 plus 1 plus 0 plus 0 plus 1 plus 1 plus 4 over 8, which is equal to 12 divided by 8, which is equal to 1.5. Part C. To calculate standard deviation, we now find the square root of variance, which you can try by yourself. Take about 30 seconds to find the standard deviation. We know that standard deviation equals the square root of variance, and therefore standard deviation is equal to square root of 1.5, which is equal to 1.225. Let us do another example, which reads: in an agricultural research center, the length of a sample of 50 maize cobs were measured and recorded as shown in the frequency distribution table below. Part A. Calculate the mean. In this example, the table is shown as a frequency distribution table where the length of each sample is given and its frequency. Let's check the table below, where X represents the length and F, the frequency, represents the number of combs, and Fx represents F times X. Apply the formula of finding the mean, that is, summation of Fx over F. That is Fx divided by F, where Fx is the sum of all data and summation of F represents the total number of items. Now, calculate Fx and find the mean. Take 2 minutes for this activity, and again, you are expected to pause your video for the 2 minutes as you work. You will find that the mean is 843 over 50. That is 843 divided by 50, which is equal to 16.86. Part B. Calculate variance and standard deviation by completing the table below, where X represents length of sample, D is length of sample minus mean, that it is the deviation, then D squared is the square of deviations, and F is frequency, that is the number of combs. And FD squared is frequency multiplied by D squared. Now, take 4 minutes to complete the table. Again, you are expected to pause your video for the 4 minutes as you work. Apply the formula for variance, which is equal to summation of FD squared over summation of F. Then variance equals 862.02 divided by 50, which is equal to 17.2404. Now, try to calculate the standard deviation and just take 30 seconds to calculate the standard deviation. You find out that standard deviation is equal to the square root of variance. Therefore, standard deviation equals square root of 17.2404, which is equal to 4.152 to 4 significant figures. In this section, we will solve the last example done, again using Casio FX82EX, a non-programmable calculator, in order to reduce time while calculating. First, click Menu, then press 2. To log in to Statistics, press 1 to activate one variable. On the screen will appear one column that represents X. To activate frequency, press Shift, then Menu, scroll down and select Statistics, and press 1 to turn on frequency table. Now, input the data from the table into the calculator in the X column. Input 9, followed by equal sign, then press 12, followed by equal sign. Input all data in X column in the same way till length 24. To input the frequency data, click on the right arrow and move up by pressing the arrow up. Input the data frequency by pressing 4, followed by equal sign, then press 7, followed by equal sign. Input all data in F column in the same way till number of combs 5. When this is done, press AC, then press Option key, then press 2, one variable calculate, and all answers will appear in one screen, and if you need to have more results, scroll down. In this section, you'll practice yourself what we have covered in this session. Assignment 1. Explain how measures of dispersion, more so standard deviation, can be applied in real-life examples or situations. Example 2. The marks obtained by 10 pupils in an English test were 15, 14, 12, 13, P, 16, 11, 13, 12, and 17. The sum of the squares of the marks is 1794. Calculate 1. The value of P. 2. The standard deviation. Thank you very much.